All right, here we go. Geometric sequences. So we're gonna I'm gonna show you how to sum up part of these guys as well. So for a geometric sequence, remember that's a sequence that repetitively multiplies by the same number every time. That same number is called R, your common ratio. Okay, so if you multiply by 2 every time to get the next number in a sequence, that is a geometric sequence. The A is the very first term in that sequence. And to find the nth term, you can use this equation right here. A sub n equals A, which is your very first term, times your ratio to the n minus 1. Remember, repetitive multiplication is an exponent. Hence, that's why n minus 1 is in the exponent this time instead of down below. So, all right, let's go ahead and look at number 25, or slide number 25. We already talked about it. R is the common ratio. So if we have this sequence and we need to find the common ratio, one thing that we can do is we can always take a term and divide by the one previous. Now you guys can probably look at this and say, oh, to get from 3 to 6, I multiply by 2. To get from 6 to 12, I multiply by 2. 12 to 24, multiply by 2. So I'm repetitively multiplying by 2. That is your common ratio. We could have also taken 6 divided by 3, that's 2. 12 divided by 6, that's 2. 24 divided by 12, that's 2. So in other words, if you take any term and the one previous to it and divide them, they need to come out with the exact same ratio, which is 2. Now, here we go. Here we go. Here we go. So to find the nth term, a sub n, we take the first term, which is 3, times our common ratio, which is 2, to the n minus 1. There's an equation for the nth term. Done. Okay, let's move to slide 28. 28 says, here's our sequence, 2, -10, 50, -50. Maybe you see, to get from 2 to -10, you multiply by -5. -10 to 50, multiply by -5. 50 to -250, multiply by -5. If not, divide them. And you'll see that your common ratio is -5. So, to find the nth term, a sub n, we take the first term, which in this case is 2, times our common ratio, -5, to the n minus 1. Again, why is the n minus 1 as an exponent? Because I'm repetitively multiplying by something which is an exponent. All right, let's slide now to slide number 30. It says, oh, actually maybe, yep, let's slide to slide number 30. It says, here's our sequence. They want an equation for the nth term. Well, if you can't see from 1 to 1/3, you multiply by 1/3. Maybe you want to divide. 1/3 divided by 1 is 1/3. Maybe you take 1/9 divided by 1/3, which is 1/9 times 3 over 1, which 3 goes into 9 3 times, so it's 1/3. If you took 1 over 27 divided by 1/9, again, you would take 1 over 27 times 9 over 1. 9 into 27 is 3, so that's 1/3. Our common ratio is 1/3. So we would get a sub n equals our initial term, which is 1, times 1/3 to the n minus 1. That's for any n. You'd find it. It's right there. Okay, let's look at slide number 34. So slide 34 says, well, first of all, find the common ratio. Again, maybe you see it. From 5 to 15, that's a multiply of 3. 15 to 45, that's a multiply times 3. 45 to 135, that's a times by 3. If not, divide them. You'll see it. Our common ratio is 3. Our a sub 1, our initial value, is 5. So the nth term in the sequence would be 5 times 3 to the n minus 1. And we're done. Pretty easy stuff. That's what I'm thinking. There's our common ratio 3. There it is. Oh, they wanted the 8th term. Well, then we would use our equation to find that 8th term. So we just plug in 8. So we get 8 minus 1, which is 7. 3 to the 7th times 5 is 10,935. Okay, that's simple, that easy. Now let me show you how to do a partial sum. So if I'm going to add these up, if I'm going to add a part of these geometric ones, it's a fairly not too difficult process. this slide here, 38, kind of shows you how they get it. You'll see that here's your sequence. And then they're going to say, let's sum it up from k equals 1 up to n. So in other words, this is our normal geometric series. We're going to go all the way up here. Now, if you look at it, you can kind of look this through and see that this part right here is exactly the same as this part right here. Which means to find, if you were to subtract those, we would get this equation. And that tells us then, this is the biggest one that we want you to memorize for geometric. For geometric, memorize S sub n equals A, which again is your initial or first term, times 1 minus r to the n, all over 1 minus r. I like to put parentheses around those two guys just to remind myself. But there it is. So let's look at an example here. It says find the following partial sum of a geometric sequence. So we have 1, 4, 16. Okay, so first of all, we see the common ratio is timesing by 4 every time. So there's our common ratio of 4. So we want S sub, we got to figure out what that n is. We don't know how many terms we're doing. That's the one thing we don't quite know. Okay? So we got to find this number that's going to go right there. Our first term is 1 times 1 minus r, which in this case is 4. And again, we don't know what power it's going to, so we need to find that number right there, over 1 minus 4. So, what term is 4096? Well, I know that 4 to the n minus 1, which if I put in 1, I get 1 minus 1, which is 0. 4 to the 0 is 1. So therefore, the question is, where does 4 to the n minus 1 equal 4096? So where does that happen? That is the question. So we need to solve for this. So in other words, we need to rewrite 4096 to some exponent. 4 to some exponent. So if you take your calculator and you start taking 4 to certain powers, I'm pretty sure that if you take 4, well, we do know that I'm pretty sure, in fact, let's check it on our calculators. I don't know, just take like 4 to the, say, 6th power. What's 4 to the 6th power? That's 1024. So 4 to the 7th power is going to be 4096. So this is 4 to the 7th power. That equals 4 to the n minus 1. So if that's true, n minus 1 equals 7, n equals 8. Is that right? I'm not sure if that's right. Hold on. Let's see. Okay. Oh, they said 4 to the 6th power. Maybe I did that in my calculator wrong. 4 times 4, 5, 6. Yep, that's right. Sorry, I'm wrong. So back here, this should have been n minus 1 is 6, because this is 4 to the 6th power. So therefore, n equals 7. So this is 7, s sub 7, so that means it's going to be 4 to the 7th. So if I plug that in my calculator and I do the math, then I get out 5,461. Okay? Make sure you plug in your calculator, make sure you can do it, make sure it comes out to be 5,461. All right, let's go ahead and take a look at another one. Let's look at number 43. So 43 says an infinite series. Now this is an infinite series going on forever. That's what the dots mean. The dots mean it goes on this way forever. And you might say, well, okay, will an infinite series ever reach a number? And the answer is yes, it will. Sometimes an infinite series will reach a number. Sometimes it will not. But how do we determine that? And we are going to learn that in our next video, because I'm going to stop here so I don't run out of room. So get ready for our next video. We're going to talk about infinite series. It's going to be lots of fun. See you soon. Bye.